Hi, my name is Jack Nguyen, and today we are going to talk about changes of state. Before we start, let's talk about the definition of a state, or also referred to as a phase. A phase is any part of a system that has uniform composition and properties. For example, this water bottle. That is consists of a liquid phase and a gas phase. On a molecular level, the liquid phase is composed of slow-moving water molecules that are connected to each other by intermolecular forces, while the gas phase is composed of fast-moving water molecules with weak or no intermolecular attraction between them. Meanwhile, let's talk about phase changes. So the main principle behind the change of phase is energy. Recall that solids are composed of molecules that are fixed in position and bound by intermolecular forces. When you heat up a solid, it turns into a liquid and eventually into a gas. This can be explained by the relationship between molecules and energy. Here is a visual representation of a solid molecule. Solid molecules are bound by intermolecular forces, and when it receives energy, it attains a higher energy state and allows it to move faster, which makes it become a liquid molecule. A liquid molecule, then, if it continues to absorb energy, it attains the highest energy state and could move extremely fast and ignore intermolecular forces, making it a gas molecule. So when a molecule receives energy, it can move faster, and this accounts for the reason behind the changes of phase. For normal phase changes, when the solids absorb energy, it becomes a liquid through the process called melting, and when a liquid receives energy or heat up, it becomes a gas through a process of vaporization. In contrast, when a gas releases energy, it turns into a liquid through condensation. Meanwhile, as the liquid is cooled down, its molecules releases energy and slows down, which eventually freeze into a solid. There is a phase change that only happens in extreme condition, which is sublimation and deposition. Sublimation is when the solids directly turns into a gas, and deposition is when the gas directly converts into a solid. This only happens at extremely low pressure and temperature. An example of sublimation would be dry ice, or an example of deposition would be the formation of frost. Now I'm going to perform a phase change of water from its liquid to gas phase. In order for complete vaporization to occur, water has to reach a boiling point, which is the temperature at which vapor pressure, caused by the already present gas molecules, to be equal to the atmospheric pressure. In order to do that, water molecule will absorb energy in the form of heat and move faster, and as more water molecules enter the gas phase, then this vapor pressure inside will increase, and as the vapor pressure inside increase, it boils. When the water temperature reach 100 degrees, the vapor pressure inside of the system will be equal to the atmospheric pressure. So therefore, at 100 degrees and 1 atmosphere, that is the normal boiling point of water. If I were to leave the system alone over a period of time, the liquid phase will completely turn into gas. And this is how energy plays a role into the phase change from a liquid to a gas phase of a substance. Finally, let's talk about phase diagram. A phase diagram is a graph of pressure versus temperature that shows the condition under which the phases of a substance exist. Here I have a sample phase diagram for water. The easiest way to look at it is to think of this as a graph. For example, the y-axis would represent pressure, while the x would represent temperature. The shaded areas of this graph represent the state of water at different pressure and temperature. The easiest way to understand a phase diagram is to take a point of reference. For example, at the pressure of 1 atmosphere and at the temperature of under 0 degrees, which is the normal freezing point of water, water will only exist as a solid. If you were to increase the temperature past into the range of 0 and 100 degrees, then water will exist as a liquid. If you were to increase the temperature to over 100 degrees, which is the normal boiling point, water will only exist as vapor or gas. I mentioned before that sublimation and deposition can only happen at extremely low temperature and pressure. Well, here it is. Now let's talk about the critical point. The critical point indicates the critical pressure and the critical temperature. The critical temperature being the temperature above which the substance cannot exist as a liquid. Simply put, if the temperature for water is greater than 373.99 degrees Celsius, then water will exist only as a gas. The critical pressure, on the other hand, is the lowest pressure at which water could exist as a liquid at the critical temperature. If you were to decrease the pressure at the temperature of 373.99 degrees, then water will exist as a gas. Finally, we have the triple point. At the pressure of 0.0060 atmosphere and at the temperature of 0.01 degrees, then water could exist as 3 stages, solid, liquid, and gas, at the same time. Now here's what it would look like.